Hello everyone, Mr. Minnick's my name, math is my game. Today in this TI Topics installment, we're going to be looking at systems. And the idea of systems is there's two or more equations, something like y equals 3x plus 4 and y equals 3x plus 5, something like that. So it's two or more equations using the same variable. And what we're going to do today is solve them by graphing, and solve algebraically. And I have to put this LOL at the end. Okay. This is a TI Topics installment. So first order of business, let's solve by graphing. If you remember, when you solve by graphing, what we're looking for is, maybe we should go to our guest speaker to explain how we solve by graphing. When we solve by graphing, we're looking to see, let's see. So we'll graph the first function. So we need to insert a graph page. So our first function was 3x plus 4, and the other one's 3x plus 5. So we have 3x plus 4, and then the next one, we press tab to get the second command, and this one's 3x plus 5. And when we solve by graphing, we're trying to find out where the two lines meet, where the two lines intersect. So maybe we need a better window. Maybe we want to do a zoom fit. Maybe that's not going to work. Maybe we want to zoom in right there and zoom in a little more and zoom in a little more. And we're trying to find out where these lines meet. Well, if we know anything at all about lines, in geometry, when you study parallel and perpendicular lines, you know that parallel lines have the same slope, and they, by definition, don't intersect or don't meet. So the deal is, if we had a system such as this, we would say that this is no solution. Okay, or the solution set is empty or null or void. Okay, so there is no solution because they're parallel lines, they're not the same line. Okay. So we can use our TI-Nspire then to solve that, and actually we don't solve it. If we tried using our special eyes and find the intersection, there's no intersection found, and so there's no solution. Okay? Well, that takes care of that. Now, solving algebraically, LOL, I'm anxious to see what would happen. So we could use the reflexive property, and since y equals y, we could say that 3x plus 5 equals 3x plus 4. If we subtracted 3x from both sides, we're left with 5 equals 4, which seems to be, I know in my advanced math classes I remember seeing these arrows that go like this. That means that it's a contradiction, and it's false, and because it's false, that tells us that there's no solution. So I wonder what that's going to play out like on the calculator. So on the calculator, if we're in a calculator page, we want to algebra, solve system of linear equations, two variables, x and y. And so we have y equals 3x plus 4. And the second equation is that y equals 3x plus 5. Enter. And it says no solution found. So the TI-Nspire is actually very intuitive when it comes to that kind of thing. Okay. So there's really two more that we probably ought to look at. And the other two that I could think of to look at would be one like this. Let's try to solve this system. Two equations, two variables, x and y. Let's go with 3x plus 5. Y equals 15, and let's go with y equals negative a fraction of 3/5 x plus 3. Okay, so we have 3x plus 5y equals 15, 3x plus 5y equals 15, and y equals negative 3/5 x plus 3 as our system. If we solve that by substitution, we would have 3x plus 5 times the group of negative 3/5 x plus 3 equals 15. And we'd get 3x minus 3x plus 15 equals 15. And the 3x's cancel, and so 15 equals 15, which is true. Scratching my head. Wonder what this is. I wonder what this is. I have no idea what the calculator's trying to say, but if I go and graph this, remember yesterday we saw that you can actually graph a standard form equation. This is so cool. This is the bee's knees, the horse's pajama, the cat's meow. Our standard form equation was 3x plus 5y equals 15, and it'll actually let us graph that. I can't believe it does that. And then our second function was actually a function, so we need to just leave this as a function, and it was negative the fraction 3/5. I said the fraction. I didn't. Let's see. The fraction 3/5. And then x, and then plus, I'm pretty sure that was plus 3. And it looks like the lines coincide, and that's in fact what happens. So the deal is the solution is any point on the line. In Algebra 1, you say there's infinitely many, and that's true. In advanced math classes, you might say the solution set is all the ordered pairs x, y such that 3x plus 5y equals 15. What that means is the solution is any point on that line. So that's what we'd see in that case. Okay. So at this time, I'd like to give a shout out to the future Mr. Minnick. I'd like to give a shout out to anybody watching at home. And we just need one more example to look at. So let's look at one where there actually is a solution. Let's look at this number 3 here. Okay. So with one like this, I say solving algebraically, LOL, because you know the Nspire, it's just so crazy how fast it solves these. We've got x minus y equals 3. We've got 7x minus y equals negative 3. Algebraically, with the elimination method, I might actually subtract the second equation from the first equation. I know it's kind of unusual to do that, but that's how I would do this. I'd get negative 6x equals 6, and so x equals negative 1. And negative 1 minus y equals 3, so negative 4 equals y. So this is telling me my solution would be negative 1, negative 4. And let's see how I did. So we got x minus y equals 3. So I'll go back to a calculator page. And again, we're using algebra. We're using solve a system. And so we have, I think it was x minus y equals 3, and 7x minus y equals something else. And 7x minus y equals, and that one's negative 3, equals negative 3. And if I did that right, negative 1, negative 4, there it is, bam. On the graph, we would have to graph that. Whoop, I inserted a calculator page. I want to insert a graph page. So on the graph, we could graph both of those. And we'll do that real quick. X minus y is 3. So we want to go menu, graph entry. It's an equation. It's a line. It's standard form. So 1x minus y minus 1y equals 3. So we graph that line. Tab, the second one was 7x minus y is negative 3. So 7x minus y equals negative 3. And we could graph both of those, and then we calculate, by using our special eyes, we calculate the intersection, and there it is, negative 1, negative 4. So that's it. It's been real. It's been fun. All the hard work that you had to do in the past with substitution or with elimination, the TI-Nspire will do for you. So see you next time on a TI topic. Have a great day.